Hello learners, today we are going to start a new topic, polymorphism in C++, types of polymorphism, compile time polymorphism, runtime polymorphism. In compile time polymorphism, function overloading and operator overloading, runtime polymorphism, function overriding, and purpose of polymorphism. These are the outline for today. Now discuss one by one. First is polymorphism in C++. Polymorphism is a third pillar of object-oriented programming system. Because this polymorphism is a wonderful concept, we will use the same name for same type of action. We will not take a different name for same type of action. We will understand this. The first, we should aware with the term polymorphism. This term is made up of by two words, poly and morphs. Poly means many, morph means forms. So it is a Greek word. We see here the term polymorphism is a combination of poly and morphs, which means many forms. It is a Greek word. So polymorphism means many forms. The word polymorphism means having many forms. Polymorphism is a feature of object-oriented programming system that allows the object to behave differently in different conditions. This allows us to perform a single action in different ways. So we will have a same type of action in different ways with the same name. In a real life example of polymorphism, a person at the same time can have different characteristics. A man at the same time is a father, a husband, and an employee. So the same person possesses different behavior in different situations. This is called polymorphism. The same person is a father, is a husband, or an employee, or same person having a different behavior in different situations. But the name of the person is same all the time. This is a real-time example for polymorphism. Polymorphism is considered one of the important feature of object-oriented programming system. In C++, polymorphism is mainly divided into two types. Number one, compile time polymorphism and runtime polymorphism. Compile time polymorphism is also called static binding or early binding. Runtime polymorphism is also known as dynamic or late binding. Polymorphism we can see in graphical representation. Polymorphism having a two types, compile time polymorphism and runtime polymorphism. Compile time polymorphism, function overloading and operator overloading. Runtime polymorphism is function overriding or virtual functions. Compile time polymorphism in C++, it is in detail. The overloaded functions are invoked by matching the type and number of arguments. Here we are implementing the concept of function overloading. The function overloading we can achieve by using two ways. Number one, by changing the number of arguments of the function. Number two, by changing the data type of the arguments of a function. Therefore, this information is available at the compile time. We have two phases of our execution of a program in C++. Number one, compile time phase. Number two, runtime phase. At the compile time, our system checks for the error in our source code. If our source code have any error in this regard, it gives us the information about the errors to be fixing. This phase is called compile time phase. So it means that the compiler selects the appropriate function at the compile time. Whenever if our source code is not having any error, so the appropriate function will be selecting at the time of compilation of the program. Which action will be performing at runtime, it has already been selecting at the compile time. It is achieved by function overloading and operator overloading, which is also known as static binding or early binding. Compile time is also called static binding or early binding. Function overloading. When there are multiple functions with the same name but different parameters, then these functions are said to be overloaded. When we have a same function name with different parameters is called function overloading. Function can be overloaded in two ways: by changing the number of arguments and by changing the type of arguments. Example of compile time polymorphism. In this example, the programmer has two functions with the same name but different number of arguments or parameters. Based on the number of parameters the programmer passes during a function call determines which function is to be called. This particular thing has been set at the compile time. Which function to be called at runtime? It is already selected at compile time. That's why it is called compile time polymorphism, early binding or static binding. So it is considered an example of polymorphism because in different condition the output is different. If we have 2 arguments, the different output. If we have 3 arguments, the different output. If we have 0 argument, is different output. So it depends on the argument to be passing. Since the call is determined during compile time, so it is called compile time polymorphism. Now this is an example of function overloading. Here we have a class ABC. In this class we have a public section. Inside the public section we have one function. The name of the function is func. Return type of the function is void, and the argument we passed here integer type x. So here func function with one argument int x. Now we write the definition into it. Inside the definition we have written here cout value of x is. So this is only the cout object to display the output on the screen, and close the function body. Come to the next. We have seen here the same one parameter and the name of the function is same. Return type also we have used here void, but return type you can take differently. But here in this function, in this program, we have taken a same return type void in both func function, and the type of argument is different. The type of argument here is int and here the type of argument is double, but only the one parameter in both cases. Now close the function definition for func function here, second func function, and now we check the third func function. The return type is void, and here we have two parameters, integer x, integer y. Here we have two different parameters, so we can understand here we are using a function overloading. The first part, if we check the first two functions, in these two functions one is integer type parameter, one is double type parameter, but the parameter is only one in both cases. So it means this is called only change the type of argument, only change the data type of argument. Here integer, here double. So this is a function overloading, one way. Second way, by changing the number of arguments. Here we have two arguments and here we have one argument, so we change the number of arguments. So this is the another way. If we compare the first function and the third function, so we see the definition with two arguments and definition with one argument. So this is the another way of function overloading. So both ways we used in this program, and then close the class ABC. After that, to execute the class ABC program, we need first the main to be designed. Without defining a main body, we cannot execute a single statement of the program, because main is the entry point of the program. So only after implementing a main function, we are allowed to execute our program inside the framework. Int main. Inside the main we create an object of the class ABC. Object name is obj1. Which function is called will depend on the parameter passed. The first func is called. So you see here we just create object 1. Now with the help of object 1 we just bind the function passing an integer type value to it as an argument. So this will directly call to the first function, because here the parameter of this function definition parameter is integer type. So here we pass the value integer type, so it matches to the first function definition and it will show the result from here. We pass the 7 will be initialized to x and the value of x will be showing as a result. So value of x is 7 is the first achievement we received. Now the second function, we pass here the floating point value. Whenever we pass a floating point value, it will be directly jump and matches to the double x, because this value is a double type. So we will have here execution of the second function and see out value of x is the value whatever we have given in the floating point 9.132. So the value of x is 9.132 will be receiving. After that, the program control back to the third function. Now we check here, we pass here two integer type values. So if we pass two integer type values, it will be directly matching to the third function and it shows the result as per the x is 85 and y is 64. See out value of x and y is, should be r, no problem, x comma y. So value of x and y is 85 and this comma we put here, so it is showing like this, and y is 64. In this example, the single function named func acts differently. The same function is having a different definition. The same function name having a different definition act differently in three different situations, which is the property of polymorphism. So this is the way to implement polymorphism in our program. This is called function overloading. We have used the both ways here by changing the number of arguments and by changing the type of argument. Operator overloading. C++ also provides the option to overload the operators. So operators are arithmetic operator, logical operator. So arithmetic operator like plus, minus, multiply, division. Talking about the plus operator, because plus operator is a perfect example of analyzing the operator overloading. The plus operator, when we use the two numeric numbers, the plus operator will perform as a calculation as a arithmetic operation, like 2 plus 3, it will become 5. But if I write here any name of a string type value and if I use two string values and putting the plus operator in between two strings, this process is called concatenation of two strings. So it will concatenate the two strings together and you will see the appending of the two strings together. So like if we have one string ABC and we use plus operation and we have another string XYZ, so we will have a result ABCXYZ together. So this is called concatenation. The programmer can make the operator plus for a string class to concatenate two strings. Programmer knows that this is the addition operator whose task is to add two operands. So the same operator will use for concatenation of two strings and use for addition operation. So a single operator plus, when placed between two integer operands, add two integers. When placed between two string operands, concatenates two strings. So this is operator overloading. Now we see one example here. This is a appropriate example to understand the operator overloading. We use a complex number, and complex number is always in the form of real number and imaginary number. So it is a combination of real and imaginary part is called a complex number. So whenever we need to apply an operation on the complex number, so real part will be adding separately to the real part and imaginary part will be adding separately for the imaginary part, and then the both will be adding to each other, real and imaginary part. So this is the way to understand the complex number to be adding. So this is the perfect and appropriate example for operator overloading. We see here we have a class complex. In this class we have a private members, integer type real and imaginary. These are the two variables of integer type. Public member complex, whenever you see this, the same name as the class name, and it is a method, so this is a special member function. This is what? This is a constructor. This is a constructor of the complex class, and we initialize the real and imaginary part by using the value r to be 0 and I is initialized to 0 as well. Inside the constructor definition, we are initializing the data members of the class. The data members are real and image, so we are giving r value to real part and I value to the image part. Here is a semicolon in between, don't be confused with it, and then close the bracket for the constructor. So we initialize the data members of the class by using a constructor, as we know before. This is the automatically called when the plus operation is used with between two complex objects. So we first check the definition of the operator overloading, then we will check the accessibility of it. So first, the complex is the name of the class, so we are taking here the return type. So complex, then the operator is a keyword. This is a return type of operator keyword. So operator is a keyword, then the plus operation, which operator you want to be overload, you need to write like this after operator keyword. Then inside the argument you see the type of the reference to the object is complex, so this is the class type. And after that, the const keyword. Const keyword is used to fix the values, so that's why we are using here const keyword. And the ampersand of obj, this is the reference of the members of the existing class. So we will see now. First we have taken a variable of complex type, so this is called object. Okay, the reference variable of the class, so it is a complex type, so this is a type of object. Then res.real is a res object name is here, is a result. Okay, res.real assignment with real plus obj.real. Don't be confused with this. This particular read first, the right hand side read first and check here the real with obj real. This real is a new real and this real is an existing real. So existing real means from where you are taking a value. Okay, so we are taking a value from the first complex number and this value of the second complex number, and then to be adding to each other, and we just having a result of the real part by adding these two numbers. After that, the same case in the imaginary part, and we get the result for the imaginary part. Return res, so we are returning a value for the real and the imaginary both parts. Whenever we return the value for both real and imaginary, because the object is here with both, so that's why we are returning a value for real and imaginary part, and close the operator overloading section. Now here we have one more method. The name is print. The return type of the method is void, and we check here cout real. It will get the value from the real part of the complex class member, and this is only the string type, so it will be print directly because it is under the double quotes. Then the image part of the variable of the class, it will receive the value from here. Then it is only the formatting of iota with the imaginary part, it's showing the imaginary part, and endl. Then close the class. So we have here three things. Number one, the class constructor. Number two, operator overloading function. And number three, print function. So these are the three things. Now come to the main body. Inside the main body, we pass here two objects. You can say here we are passing argument to the constructor, so it is a parameterized constructor because we are directly passing the value to the object, and here also we are passing value to the object, so parameterized constructor will be calling at the same time. The first complex number C1, object with C1, so 10 and 5, so it will receives the value for R is 10 and for I is 5. So the first time the value for the real number is 5 and value for imaginary part is, value for real part is 10 and value for imaginary part is 5. Now C2, for the second object, the value for R is 2 and value for I is 4. So real part is 2 and imaginary part is 4. After completing this phase, we set the value for C1 and we set the value for C2 for real and imaginary parts as well. Whenever we call the operator overloading complex, it is a type of the third complex number C3, by adding two complex numbers C1 and C2, whenever our program will receive the addition operation with two objects C1 and C2, it will directly jump to the operator overloading part, and then whatever the value for the C1 will be receiving here, for C1 the real part is 10 and C2 real part is 2. So here 10 plus 2 will be available for adding to each other, and the value to be assigned to the result real part, it become 12. So we will have the 12 here. And then the second is for imaginary part, 5 obj.image and 4 for image, and both should be adding, and the result will be saved with 4 plus 5 is a 9. Then the return value, it will return the value to the private members of the class, real and imaginary. So real value become 12 and imaginary value become 9. After that, we have seen here the program control back again here, and C3.print. What will be the value for C3? So it will directly jump to the print method. Inside the print method, we can check here the cout statement, real part. What is the value for the real part is 12, so it will become a 12 here. This just a formatting to show the output, so we have taken here the plus, and then the image value. What is the image value now? The image value is become 4 plus 5 is become 9 here, so this value is 9, so we have received the value 9 here. Then the iota to be formatting here with the value represent of I, so we have putting here I is like that, and to next line. So this is the way to show the result for the complex number. Now control back to the main body and close the main function. It will complete the execution of the program. In this example, the operator plus is overloaded. The operator plus is an addition operator, can add two numbers, integer or floating point, but here the operator is made to perform the addition of two imaginary or complex numbers. So here we need an operator overloading, because by using a same operator we are adding number of times. We are adding one time for real part, one time for imaginary part. So this is the example of operator overloading. By adding two objects, we need operator overloading to perform this operation. Now runtime polymorphism. Runtime polymorphism is achieved when the object method is invoked at runtime instead of compile time. After compiling a program, after completing the all bindings at the compile time, we will be coming to the runtime. So whatever the things selected at the compile time, it will be execute with the same operation at the runtime. So that's why the object method is invoked at the runtime instead of compile time. It is achieved by method overriding, which is also known as dynamic binding or late binding. So we understand this. Note, in function or method overriding, the function in the parent class is called the overridden function and the function in the child class is called overriding function. So in function or method overriding, the function in the parent class is called overridden function. So whatever the function we have inside the parent class is overridden, and the function in the child class is called overriding. So remember this point. Function overriding in C++. When a child class declares a method which is already present in the parent class, then this is called function overriding. The same name method in the parent class and same name method in the child class with the same arguments. If we have two arguments in the parent class, the same two arguments should be in the child class. So this is function overriding and having a same type of arguments. Here child class overrides the parent class members. In the case of function overriding, the programmer has two definitions of the same function. One is in a parent class, another is in a child class, as I told you. The call to the function is determined at runtime to decide which definition of the function to be called. It is called runtime polymorphism. Which function should be calling at runtime, this decision should be taken by the compiler at runtime. So this is called runtime polymorphism or late binding. Function overriding is a feature that allows the programmer to have the same function in the child class which is already present in the parent class. A child class inherits data members and member functions of the parent class. It is already we have done in the inheritance section. The child class inherits the data members and member functions of the parent class. But when programmer wants to override functionality in the child class, then the programmer can use function overriding. It is like creating a new version of the old function in the child class. So we can understand here, whenever programmer wants to override functionality in the child class, then definitely the programmer can use function overriding. It is like that you are creating a new function for the old version. So you are creating a new function inside the child class. Here we can see the example. In this example we have a class A. In the class A we have public section. In public section the void display disp. Void disp is the name of the function and void is the return type. No arguments will be passing here. Cout, just display the output on the screen, and then close the function body disp and close the class. Now we have another class A, another class B. In this class B we can see we are using an inheritance concept and the public mode for the class A. So the features from the class A will be accessing inside the class B. So inside the class B definition we see the public section with the same function. The return type is same, function name is same, no argument, and then we have written the definition for the disp function here in the child class as well, and then here subclass function, and in the parent class we are using superclass function, and then close the function body, close the class body. So we have defined the class A and the class B with the same function disp. Now come to the main body to execute this part of the program. Inside the main body we create an object for the parent class and we create an object for the child class. With the help of parent class object we call the parent class data members and member functions. So we have a member function here disp, so we call it obj.disp. Inside the child class we call again for obj2 disp and then return 0. So we will see the output for first object disp. Method will be printing the value on the screen with the help of cout object, superclass function, and the same for the second obj2.disp. So it is showing the result for the second subclass function. So we have seen here the object of class A is accessing the class A member function disp, and object of class B accessing the second derived class member function disp. With the help of object 2, it will not execute the class A disp, because whenever we create object 2 and we call the disp function, it will directly come to the class B, and when it finds the definition in the class B, it will never be executing the class A disp function. So because it finds in the class B, so it will execute directly the class B member function. Purpose of polymorphism in C++. Programmer can access different implementation of a function with the same function name. This is one. Different implementation of a same function and same function name. It's number one. Second, design and implement systems that are more easily extensible. So implement the system and use to extend as per the requirement, enhance the definitions as per the requirement. For example, function overloading, operator overloading, etc. For a class, if programmer have the class shape, inside the class shape we have the public section. Inside the public section declare a void draw is a method. Just declare the method. We didn't write the definition here, and then close the class, show the pointer variable here and the object. Shape pointer ptr is the pointer variable. Shape object is the object of the class shape. Programmer can have two polymorphisms, shape pointer arrow operator draw. So we can access with the help of shape pointer variable by using an arrow operator for access the member function of the class shape. So arrow operator draw. Compiler implements dynamic binding function determined during execution time. This is called dynamic binding. It will be executed at the runtime of the program. Shape object.draw. This binding is a static binding. It has been completed at compile time. So compiler implements static binding here. Function determined using compile time. This execution is at runtime. This execution is at runtime. Oh, compile time. Sorry. This execution is at compile time. Shape object.draw. What is the difference between the compile time polymorphism and runtime polymorphism? The function to be invoked is known as compile time. The function to be invoked is known as at runtime. Here the function is invoking at runtime is runtime polymorphism. Function is invoking at compile time is compile time polymorphism. It is also known as overloading, early binding and static binding. It is also known as overriding, dynamic binding and late binding. Overloading is a compile time polymorphism where more than one method is having a same name but with the different number of parameters or the type of parameters is called overloading at compile time. Overriding is a runtime polymorphism where more than one method is having a same name, number of parameters and type of parameters in different classes. Whenever we are talking about the overriding, it means we are using inheritance concept here. When we are talking about the overloading, means we are using the same name function in the same class. But in overriding, we should implement the inheritance concept. Because of inheritance is called runtime polymorphism, because when the two objects of the parent and child classes will be communicating to each other, these objects only passing a message to each other at the time of running a program. So that's why these two objects will be interacting to each other at runtime. That's why it is called runtime polymorphism. It is achieved by function overloading and operator overloading. The compile time polymorphism is achieved by using function overloading and operator overloading. Runtime polymorphism is achieved by virtual functions and the pointers or function overriding. It provides the fast execution as it is known as the compile time. It provides the slow execution. The runtime process is a slow execution because it is a late binding. So that's why we are telling the slow execution. Otherwise, always the object is taking a very less time to execute it. So this is the fast process at runtime. But because the first we complete the phase of compilation, then the runtime. So that's why we are saying here the slow execution as it is known as the runtime. It is less flexible. Compile time polymorphism is less flexible as mainly all the things execute at compile time. Runtime is more flexible. All the things execute at runtime. This is also called dynamic binding. Thank you. Thank you so much. Like, share and subscribe my channel. If you have any query, put the comments in the comment box and I will be happy to solve it.